Good afternoon, everyone. This is the pre-launch news conference for SpaceX CRS-8, a mission to be launched on a SpaceX Falcon 9 rocket on Friday afternoon at 4:43 p.m. to the International Space Station. And here to discuss the upcoming launch and the mission is Kirk Sharman, the International Space Station Program Manager from NASA's Johnson Space Center. Hans Koenigsmann, the Vice President of Flight Reliability for SpaceX. Kurt Costello, the International Space Station Program Science Office at NASA's Johnson Space Center. And Kathy Winters, Launch Weather Officer for the 45th Weather Squadron. And we'll begin first with Kirk Sharman. Kirk?
All right, good afternoon. Thank you all for being here. It's great to be back here in Florida. I'm really looking forward to a launch tomorrow afternoon. This vehicle, the Dragon vehicle, is really important for the International Space Station. It brings some very unique capabilities to ISS that are important. One is it has an external cargo capability, which is important, and as you know, we'll be launching the Bigelow expandable module on this flight. So we're really looking forward to having that up on board ISS. Another key feature that this vehicle brings is the ability to return cargo. So not only will we be carrying an enormous amount of cargo up to the International Space Station, but we bring down critical science samples as well as failed hardware from the ISS, as well as some removing some trash. So the ability to bring that cargo back down to the ground and get those results and that hardware so that we can repair it is a really key capability in allowing ISS to continue its function as an outstanding, one-of-a-kind research laboratory in space. This week, this launch really culminates a very busy season on board ISS. There's some unique things about this. One is we'll have when Dragon gets on board, we'll have the first time ever 2 USOS visiting vehicles, cargo vehicles, berthed to the International Space Station at a single time. So the first of many that I hope, but that'll be a unique configuration for the International Space Station. So we're looking forward to that. One of the biggest things from an on-orbit operations point of view, though, is the fact that this will bring to the close a very busy season of visiting vehicles. So when Dragon arrives on Sunday morning, it'll close a period of 4 visiting vehicles in 4 consecutive weeks. So we had the Soyuz launch, we had the Cygnus launch, we had the Progress launch, and now we'll have Dragon launch. So a very, very busy time on orbit. So we're looking forward to that. The consumables on board International Space Station, because of the visiting vehicles that we have, are actually in great shape, a very robust shape, and in fact the best shape since we had the disruption in our supply chain here last year. So it's really important to have a very regular supply chain. Not only from a consumable standpoint, but even more importantly from a standpoint of research and utilization. In order to do the research that we do on ISS, it's critical that we have a constant supply chain coming up and coming back down. So again, we're looking forward to this flight to really set the tone and get us back into flying on a regular pace. And finally, the on-orbit activities that we have planned coming up. Of course, this week actually marks next week actually marks the second biggest week in terms of crew time for utilization that we will have had. And it's really associated with the bringing up the experiments here on SpaceX. So we're looking forward to setting new records as we go forward in terms of crew time used for utilization. And with that, I'll hand it back over to you.
All right. Thank you, Kirk. Now to Hans Koenigsmann, the Vice President of Flight Reliability for SpaceX. Hans?
Yeah, thank you, George. I'm glad to be back in Florida, glad to be back in CRS launches, and this is particularly important for us because it is the first launch for CRS on an upgraded vehicle. I do have to point out the vehicle itself has flown before. We had 2 successful launches. One in December, an OPCOM mission, and one in March, early March, an SES mission, so we know the vehicle very well. But this is the first time we launch a Dragon on this particular vehicle. So it is a standard trajectory, like the previous launches, going into a 200 by 360 kilometer orbit just under the space station, obviously the same inclination. And then Dragon will be deployed and will work its way up to the station within the next 2 days, roundabout. The first stage landing is going to be on a drone ship. It's going to come back partially. In other words, the drone ship is kind of like halfway where the splash point would be. And I certainly hope we're going to nail the landing this time. On the Dragon front, as Kirk pointed out, the Dragon is pretty full. It's a 3,800 pounds in the pressure section, full of signs and cargo for the space station. And then in the trunk section, the unpressurized part of Dragon is going to be the experiment is called BEAM, Bigelow Expendable Activity Module, and it's basically a mini inflatable space station, which I think is very exciting. I'm really glad that another commercial company is doing big experiments with the going to space, and I think this particular experiment has great potential for building a new space station, extending the current space station, and so on and so forth. So it's a really exciting experiment. We just completed a static fire yesterday. It went very well. We just had our launch readiness review, and everything is good to go at this point in time. So things are looking good, and I do want to point out lots of people work on this. For us, it's the crew here at the Cape that performed marvelous and does basically the vehicle integration, troubleshooting, and then actually the static fire and the launch. So shout out to that team. Also the Texas crew that delivers a vehicle that's been very well tested and ready to launch. And then, as always, I want to take the opportunity to thank our partner NASA and also the FAA and the 45th Space Wing for their support.
Thank you, Hans. Now to Kirk Costello, the International Space Station Program Science Office at NASA's Johnson Space Center. Kurt?
Thank you, George. As Kirk pointed out earlier, there's a huge amount of cargo and particularly utilization coming up to the space station on the SpaceX Dragon CRS-8 mission, and we're very excited to have that capability there. We have over 4,300 pounds of utilization cargo flying to station. 3,100 pounds of that is the beam module. And very importantly, the SpaceX gives us the return capability we need to get samples off of space stations, samples that have been collecting and contain the remainder of the one-year mission samples that Scott Kelly just completed on orbit. We're very excited to have those back and begin the analysis for those samples. To start off with, I'd like to talk about some of the investigations that we're very proud that SpaceX, the National Lab, and NASA were able to continue to get manifested and refly as they were investigations that were lost on the SpaceX 7 and Orb 3 missions. We have microchannel diffusion, which is Dr. Alessandra Grattoni from Houston Methodist, who will be flying a fundamental fluid physics nanoparticle delivery system to examine the fluid physics of how drug implant delivery systems can be used in microgravity. Wet Lab 2, Julie Schoenfeld. This is a DNA RNA amplification system and a sample analysis system that reduces the overall crew time associated with these and also relies on qPCR to be able to do gene expression analysis in situ. We're very excited to have that on board. And last but not least, one of our student investigations from the National Center for Earth and Space Science Education is flying. It was originally scheduled on Orb 3. It was also on Orb 7, and now we finally get to launch it on SpaceX 8. We're very happy they'll be flying with us, and they're doing an investigation into the formation of tin whiskers on non-lead-based solders in space, something that's plagued various spacecraft to date, and we'll be interested in them getting their investigation back. And those are the students from the Paul With Scholars Academy in South Carolina. Of course, we do have the beam module flying in the Dragon trunk, and that will be attached to station. When expanded, it will have 565 cubic feet, and we'll be outfitting it with 4 different types of sensors. Those sensors will help us determine the loads during deployment, radiation sensors, temperature sensors, and also distributed impact sensors to understand how micrometeoroids may impact that part of the vehicle. SpaceX 8 is an amazing bonanza for the biological sciences. If you look at all of the biological sciences involved in the SpaceX 8 cargo manifest, you'll see that we're bringing on new commercial companies through the National Lab. We're bringing on research lines that are very critical to the space station, use philosophies such as rodent research associated with Eli Lilly. Dr. Rosamund Smith will be looking at myostatin antibodies and how they can reduce muscle wasting that occurs in the microgravity environment, and how that same reduction in muscle wasting may help the skeletal loss of bone that occurs in those situations. They'll also be doing protein crystallization experiments by Eli Lilly, and these involve some new partners in terms of the protein crystallization cards that we'll be flying. The cards themselves are called the MightyGen plates, and they're new 96-well commercially available plates, and hopefully will offer a better, more commercial access to protein crystallization facilities on board the station. They'll be looking particularly at how some of the membrane proteins associated with certain cancer lines, when grown in the presence of medically relevant molecules, crystallize and hopefully be able to bring those back down to the ground and get better diffraction maps of those proteins. And we also have another student competition that is flying this time. The Boeing company sponsored the Genes in Space competition, and the first winner from that competition will be flying. Hopefully you saw her earlier today in the What's on Board section that we had. Anna Sophia Bogorayev, is flying her experiment. It's a 2-phase investigation that we'll be doing. First, we'll be trying to validate some hardware known as a mini PCR system that does polymerase chain reactions for genetic analysis on board. Once that's validated, she'll be looking into her hypothesis, which is that epigenetic changes can be tracked on board in situ using this device. So we're very excited to have her, and she is an excellent presenter. We had her here earlier today. Last but not least, we've got a number of other biological investigations going on. The VEGO3 experiment will be looking at how we can grow new plants on board and help us in our journey to Mars. We'll be looking specifically at how to grow a Chinese cabbage variant. Micro 9 and Micro 10 are both microbiology experiments. One is a yeast colony survival experiment, and the other is using aspergillus, a certain type of fungi, to grow medically relevant secondary metabolites. So items that can be grown in space and possibly used for the production of drugs. And finally, Microbial Observatory 1 is completing its investigation with this SpaceX 8 launch and return, and we'll be bringing back samples of the microbial contents of the space station and analyzing the change over time. And that's Venkat Shwaran from JPL. Thank you, George.
Thank you, Kurt. And we'll look now at the weather forecast for Friday afternoon. Kathy Winters from the 45th Weather Squadron. Kathy?
Thanks, George. Well, weather looks great for launch. I mean, it's just going to be a beautiful day, both for launching and also for viewing a launch, because we do have just a front that's rolling through today, but tomorrow is just going to be a little bit breezy with mostly clear skies, just a few clouds out there, and temperatures will be in the mid-70s, so it'll be a great day to launch a rocket. Let's go ahead and look at the satellite picture. You can see on our satellite picture that we had a front roll through. It's rolling through Central Florida today, and there were some isolated showers in the area this morning, but they're all pushing off to the south and east. And behind that, there's actually going to be another push of cold air that comes in tomorrow afternoon, but it's going to be very dry with no significant weather for launch, so just a little bit breezy out there and mostly clear skies. Looking at our launch forecast, you can see that we do have just winds expected to be from the west. Again, a little breezy, gusting up to 20 miles per hour. Temperature will be around 75 degrees at the launch pad, and about a 20% cloud cover in the area. So again, a great day to view a launch as well. We only have a 10% chance of violating launch constraints, only due to liftoff winds. We aren't concerned about violating any of the Lightning launch commit criteria. If we happen to delay 24 hours, weather looks great. Again, it's just a great weekend also to launch a rocket. The winds shift around to the northeast, about 18 miles per hour be the highest that I think we'll see, with temperature a little bit cooler, 70 degrees, and cloud percentage increasing just slightly to a 30% chance, but they'll be very thin. We're not looking for any significant development with clouds. We just, again, have a 10% chance of violating launch commit criteria due to weather, and that is the only concern is the cumulus cloud rule for Saturday. So overall, it's a great day to launch. Our launch weather officer is going to be Captain Laura Godoy, and she's really looking forward to it, and we're looking forward to it as a team from the 45th Weather Squadron.
Thank you, Kathy. And we're ready now to take questions. So please give your name and affiliation when the microphone comes to you. We'll start here in the room, and then we'll go to social media. So, Marcia?
Marcia Dunn, Associated Press. Two quick questions. First for Kirk Sharman. Could you just touch on the historical significance of the first expandable module launching for astronaut use? And for Hans, why try for a drone ship? Why not just come back to the land landing?
So, we've been looking at, and I say we, NASA, but really I'd say the spacefaring world's been looking at expandables for quite some time. In fact, early on in the space station program, back in the 90s, we started talking about an expandable module. You can launch it, and one of the two big issues with launching to low Earth orbit are mass, but probably even more so than mass is volume. And so how can you package something in a small volume to fit inside a fairing on a rocket, get it through the atmosphere, and then have it expand to be a larger volume to live and work in? And so expandables is the answer to that question. So it's really great to actually have one fly up and be part of International Space Station. I understand that Bigelow has flown a couple of those in the past on expendable launch vehicles, but this will be the first one where we actually have humans interacting with that module. So it's great. There's the devil's in the details. So there's all these details associated with actually expanding a module and then actually using it. And the beauty is that's what we're going to be doing and what we'll be learning. So I think it is the future. We'll be using these. Humans will be using these kinds of modules as we go, as we move further and further off the planet, and actually as we inhabit low Earth orbit. So I think it really is the next logical step in humans getting off the planet.
Yeah. Regarding drone ship versus land, I probably have to explain a little bit that on the landing on the drone ship is it's harder to land, but it's actually easier for the rocket to get back to the ship. You can put the ship in any place that is safe, and so overall this is a little bit of a trade. Landing on land on the other side is easier for the landing itself because you have more space and it doesn't move that much. And on the other side, for the trajectory, it's the harder part to get back to land. So on this particular flight, we decided we want to go to the drone ship and see if we can get a successful landing on the drone ship done. Partly also because the next flights, the next 2 or 3 flights are going to be drone ship landings. There's no choice there. Because we can't get to land. So it's a good opportunity for us to to refine our drone ship landing capabilities and get this done. Because in the long run, that is certainly something that we need to demonstrate over and over again to get the first stages back.
Right, Daryl?
Daryl Nail, Fox 35. Question for Hans. What kind of changes, did you make to the Falcon 9 since CRS-7? The most important changes? And what's your confidence level going into launching this Dragon spacecraft with that rocket for the first time?
Yeah, so following CRS-7, we made a change on the strut system, basically inside the tank, and I'm actually very confident that that was the problem that addressed everything since we launched twice, well, technically 3 times. After that that change was made, there's that pretty much sums it up. There's minor changes on the nuts and bolts level, but that is basically all the changes we did. Now you do need to understand the CS7 was the what we call the 1.1 version, and this is the upgraded version. So there's additional changes that were phased in as a block upgrade, and that's higher thrust. We're using densified propellant, and the vehicle is slightly couple feet longer than the 1.1 version. So there's two reasons to make changes here, basically, and those are combined.
Bill?
Bill Harwood, CBS for Heinz. Just a really quick question. The upgraded rocket, is that all you're going to do from here on in for the Falcon, or you still plan to fly any 1.1 variants in the... Go ahead, I'm sorry.
Yeah, that's correct. It's going to be the upgrade version from here on, and yes.
Does the densified propellant do anything to help you on a CRS mission?
Yeah.
Or is that what's it buying you in this case?
Oh, in terms of numbers, it buys you a couple percent, basically, in terms of payload capability, or probability to get back to land, or probability to get a good landing on a drone ship. It basically means you get into the same rocket, you get more propellant, and it's pretty significant. It's the order of 5-6%, something like that, maybe even more. I haven't looked at the numbers myself, but it is a substantial improvement worth the effort.
James?
Thanks, James Dean, Florida Today. Hans, that densified propellant, I know you've launched it successfully a couple times now, but it has seemed to have given you some trouble during several countdowns, not getting the right temperature, apparently. It seems to have also limited your ability to take advantage of longer windows when you have them. So can you just describe where you're at with that? Is
Right.
this, how much, do you have this thing down, or is there still things you have to learn about this? I'm also just curious, Kirk, if from NASA's point of view, if you had to see this rocket launch a couple times before you were willing to get another CRS mission going, or whatever review of this rocket you did.
So for CRS, actually, what happens to the propellant is once you load the propellants, they warm up, and so you have a limited time. You can keep the propellant in the vehicle before you must go, or it gets too warm. For CRS missions, that doesn't make a difference because we use instantaneous launch windows to catch up with the ISS. So it is basically transparent for these missions. For other missions, we are working how to recycle and how to make sure that we have the right temperature propellant on board. And in general, you're right. We're working through some of those issues on the ground side. The ground side is now needs to chill at very low temperatures, and that obviously is something that it is difficult to test without a rocket. So when you put the rocket the first time on the launch pad for a static fire and then for a launch, you learn things that you're going to improve on the next time. I'm pretty sure we have learned the most of it. I can't promise we learned all of it. That would be not correct to say, I think, but we learned a lot, and I feel like we got this relatively well under control at this point in time.
And so you were asking about what we did, what NASA did in terms of reviewing the preparations for this launch and whether or not we wanted to see multiple launches. In one sense, the statistician in us all would love to see launches before yours, you can establish kind of what the probability of success is. But the work done to really assure that we're comfortable is the same, whether it's the first rocket or the third rocket. So we've been participating very closely with SpaceX throughout the whole process, through the manufacture, the test in McGregor, Texas. All the issues that were found along the way and how SpaceX mitigated those risks. We've been working very closely with them, and SpaceX has been very open. We would do that if this was the first rocket, or if it's, in this case, it's the third full thrust variant. So we do the exact same thing. Technically, we do that same work. The question is, what are the unknowns, the unknown unknowns? What don't you know? And of course, that's why if you're the second or the third guy, you get to see a little bit of that. But we would have, had we been the first one, we would have been happy to be the first one. And as you'll see, in a launch later on this calendar year, we'll be the first person on a new rocket. So you just have to do the technical work, and if you do that work, then NASA will be comfortable in launching.
Yes, right here.
Mark Gotch, Historical Space Imagery. This question is for Hans. Hans, could you tell me, the Falcon 9 rocket, in terms of it with the Dragon, again, can you fully explain the changes that were needed to incorporate it being used on it? Also, can you tell me, why was the Falcon 9 never used before to incorporation with the Dragon? Can you also tell me this, that the SES mission that SpaceX had, in that launch, we noticed one thing, and that was when the separation did come heading for the barge platform, we actually did get to view it going across rather low. Atypically, how high would the barge landing attempt moving over from separation B? And again, it is computer controlled, therefore we were wondering, why did we see it much lower?
There was a lot of questions. I tried to answer all of them. So first of all, there's the Dragon. There's the Dragon version and the satellite version are basically identical, with the exception of the front part. There's a part that holds Dragon to the vehicle basically, and has a deploy mechanism and takes care of some of the those Dragon specific integration things basically. And then there's the satellite version, where the satellite is mounted inside the fairing, and then you have these relatively large fairing encapsulating it. Those are the main differences from the vehicle. Everything else is the same. And then of course the software or the configuration going to different places is also a slight difference. In terms of, and so when I said this is the first flight of a CRS mission on the upgraded vehicle, I was specifically referring to the upgraded part here. It's the first time we fly the densified propellant, slightly longer vehicle compared to the 1.1 version. However, we've flown the 1.1. It's hard to tell actually from the outside what changed on the vehicle. They look very similar, and we've flown that version, I guess 6 times. On CRS and a couple times on the COTS mission too. So from that perspective, I didn't want to say that this is brand new or there's anything different, significantly different here. I just wanted to point out it's an upgraded version, and it has a little bit more performance overall. So in terms of comparison to the SES mission, I'm not quite sure what you're referring to, but whether you mean the stages flipping around or the trajectory itself.
Is we did see the trajectory after separation of it heading to the drone ship.
Yeah.
It was rather low. Atypically, it would be higher. Am I incorrect in my assumption?
I think you have a point in the sense that the geostationary trajectories are really low when they at the perigee, and the obviously the higher you go with perigee, the more work you have to put in there. And the goal is here to have a really high velocity vector at perigee, so that the apogee on the other side basically is really high. So it may look that this is lower. honestly, I've never seen a launch from the outside, so I can't tell. And Dragon on the other side has a higher perigee, so it might be that you're right that at separation it looks like the trajectory is lower. I'm pretty sure the geotransfer orbits are as low as it gets in general, so that's probably the lowest you will ever see. It's still pretty high. It still reaches the first stage reaches an apogee of a couple of 100 kilometers. So from that perspective, I'm surprised you can see this from the ground, actually.
Irene?
Thanks. Irene Klotz with Reuters. I have two just quick clarifications for you, Hans, and then a question. Is it correct then that you are characterizing the drone ship landing as a test, and this rocket could return to land if you had chosen not to do the drone ship test?
I'm not sure, honestly. I think it's pretty close. It should be able to get back to land, but I haven't run the number. I think the drone ship landing itself is the more benign trajectory, and so people might have chosen this on our side to make a safe drone ship landing, because this is the time we need to verify that we can do the drone ship landings. It's still an experiment, no question about it, and it is still. It has always been a fairly high risk to landing itself, obviously not to the main mission. I do want to point out that those two parts are completely separate. We put a lot of effort in the main mission to make sure that the CIS part of the mission works flawless, and then on the drone ship landing, we've been taking risks on our side, basically, as you have seen in the past.
Okay, let's take one more question here. Okay, go ahead, Ari, finish up.
Thanks. And on the fuel densification, you said because it's an instantaneous launch window, you don't think that you're going to get into the issues that you had on the
Right.
last flight. And then the other, Gwen Shotwell had said that with this flight, SpaceX intends to really step up its pace of launches. Can you address, I guess from your perspective, and
Yes.
I don't know if you have a new job title, if it's related to that, but what what SpaceX is looking at from here on out as far as a cadence?
So, well, maybe first the new job title is basically transparent. I used to be mission assurance, flight reliability. The team is the same. I feel flight reliability and addresses better what we do, actually. I can do, it's easier to explain for that matter. In terms of pace, it is true we have to pick up the pace, and we will pick up the pace. And honestly, it's I'm nearsighted in terms of what the mission manifest says. I see the next 2 or 3. The one after this is currently by the end of April, and I believe there's another one in May, shortly thereafter. So the time between the missions will get shorter and shorter. It is something we've seen with the 1.1 version 2. When you phase an upgrade in, you need a little bit of time to between the launches, and then after a while you pick up the pace. And we hope we're going to be able to launch basically every other week, by the end of this year, and then maybe even increase the pace overall.
Okay, we'll take one more question before we go to social media.
Hello, Kyle Brown with U.S. Launch Report. This question is for Hans. Looking towards the future, will the Falcon Heavy maiden launch be carrying a Mars-related payload? And also, will SpaceX be carrying up the next international docking adapter? And if so, has that been planned ahead?
The docking adapter is probably a question for...
Yeah, docking adapters at SpaceX 9, so the very next SpaceX flight to ISS will be carrying up the international docking adapter, the first international docking adapter to be installed on ISS. So there is another one planned for next year. So we'll have 2 to support commercial crew.
And I got to disappoint you on the other question. I don't have any information on the Mars, related to Falcon Heavy. Certainly, the Falcon Heavy is capable of running bigger payloads or payloads that need higher delta V. That's certainly possible, but I have no information regarding that.
Okay, let's go to social media, and then we'll come back here to the hashtag Ask NASA if you have a question. And Stephanie, what have we got?
So we have several questions coming in from social media. The first one is from Leander Jansen, and he would like to know what are the challenges to land now, and more specifically, is SpaceX more confident in the landing legs, and are there any differences from the Jason 3 landing legs?
I guess that goes to me. So, yes, we are more confident, and we have more confidence in this landing leg than in the Jason 3 landing leg. Yeah, I've got to be careful to keep my mission straight here. I mean, obviously, we learned at Jason 3 that how to improve the landing leg. We didn't get a chance to test it out in SES 9, but we're pretty sure that we found the problem. One of the advantages is to some extent that you get the hardware back, and so you can actually look at it and see what broke, what was the issue, and then go fix it and test it. And I'm fairly confident that we fixed that particular issue that we had with Jason 3.
The next question is also for Hans. The question is, will you be reusing the Dragon spacecraft in the future?
I think there's an effort underway to do this. It's something that we basically have in work at this point in time. There's certain things that come with it. You have to obviously show that you can survive the launch twice, 3 times, 4 times, and so on and so forth. But it is something that is in work.
You have another one, Stephanie?
And
Okay.
the last one, you'd mentioned the SpaceX 9 is going to launch the docking adapter. Do you have a tentative date time frame for that?
Yes, I do. Let me look it up here though to tell you, so I'll get it right. Let's see. Oops, wrong page. So we're looking in the June timeframe, late June. So I don't know that SpaceX has announced the actual launch date, but we're looking in the late June timeframe.
All right, let's come back here and take some more questions here in the room. Right back here.
Hi, Josh Jenner with the Orbital.Space. If the landing on the barge is successful for the first stage, is there any plan to refly that stage? And if not, when will we see a first stage reflown?
So it depends a little bit again on how it looks when it comes back from the barge. There's the drone ship, and so we got to take a look at the vehicle again and make sure it's flight worthy. There are plans, but it's not going to be immediately. It's going to be a couple of months until we will see what we do with the stage.
And just out of curiosity, what's the name of the drone ship?
Oh, this is Of Course I Still Love You.
All right, we have a question here in the front.
Hi, Thaddeus with the Utica Phoenix. I was hoping to speak to the Dragon's crew carrying capabilities and what we can come to expect with the commercial crew program. And as a follow-up, if we could try to do a compare and contrast to the Soyuz and the Dragon.
So I guess that goes to me.
Well, go ahead.
I mean,
I could talk too a little bit too, but go ahead.
So I just can. I know Crew Dragon isn't work. It's very intense work right now. There's the first launches are planned for sometime in 2017, and we're tracking the planned launch date at this point in time. I don't think I have anything more other than in terms of the interior and how it looks. It's a lot more roomy and a lot bigger than Proton, I think, right?
Soyuz.
Soyuz, right? Soyuz.
So we have requirements. NASA had requirements that were placed on the commercial crew vehicles. It's to carry 4 crew members. Soyuz carries 3. So, but the length of stay it needs to have on orbit, its altitudes that it has to perform are very similar to the mission, if you will. It's very similar to a Soyuz vehicle. So the mission's the same, but as Hans said, it'll be a larger vehicle because it's going to carry 4 crew members to ISS.
Stephen?
Thanks. Stephen Clark from Spaceflight Now. A couple of questions for Hans. I'm curious, you mentioned, in the coming months you hope to pace your launches 2 weeks apart, approximately. What's the constraint on that? Is it facilities? Is it personnel that determines your 2-week turnaround goal? And I have one more. Thanks.
It's a little bit all of the above, I would say. It takes, well, when you look at how companies develop, I mean, we get from this development and research, you get the rocket going, basically, and then you turn around and you have to produce this rocket now at a certain pace. That in itself is a challenge. We're pretty much at a good spot there, and then the second comes in the operations. You got to make sure that you test it on time, that you don't, that your hardware becomes easier to test, and all those things have been developed over the years. The last part then, of course, is you're at a launch site, and you got to integrate. You need enough room, enough volume, and enough capability here at the Cape, and then also at Vandenberg. So one of the advantages, we have these 2 launch sites, technically 3, and so we're gonna build them up basically and use them to their full capability, and that's part of what allows us to increase the launch rate by using basically all launch sites.
And one more for Hans. The decision between going for a landing on shore versus on the drone ship, how many missions going forward, if you had to put a percentage on it, what types of missions actually have the performance margin to come back to a landing near the launch site?
It's a good question, actually. Let me see. Off the top of my head, I would say maybe a third, and it gets better when we start flying Falcon Heavy because the side boosters can always come back. So it depends a little bit on the details there, but I would, off the top of my head, I would say a third can come back to land, and the rest is a drone ship.
Marcia?
Maybe it's 50-50, somewhere in that range.
Yes, Hans, Marcia Dunn, AP again. I remember after the last summer's accident, Elon said that he was going to activate the parachute deploy on the Dragon for the next flight so you could salvage the capsule if necessary. Has that been done?
Yeah, that's correct. If he would be in a similar situation, Dragon would deploy the parachute and would land softly in the water, and we would be able to save the science and the cargo on board of Dragon. That has been implemented.
Can I add to that if I could?
Will that be standard procedure, I'm assuming, from here on out? Standard procedure going forward?
Yes.
Yeah. So NASA thought that was a great capability to have. Certainly if a similar situation where we believe Dragon would survive. The FAA has to prove it. So since it's in launch and landing, and that would constitute a landing, the FAA has to approve it, and they did approve phase.
They did the phase up to
phase 1 and phase 2. There's a further down range which has not been approved yet, but and of course landing on the ocean's the first problem. At some point in time, you actually have to get there to get it. So obviously, if it's close by, it's not a problem. But all the logistics about going to get it is to be worked out. But we think it's a great capability. NASA's very happy to have that contingency capability in place.
So you're saying that you could, for early in the flight, you could salvage it if necessary?
It's actually not that early. I mean, I would say it's everything except the last 20-ish seconds.
Mm-hmm.
James?
Thanks. James Dean, Florida Today. Hans, just following up a comment you made a moment ago about utilizing all your launch sites. When are you targeting a first launch off of Pad 39A? And how many might you do from there this year?
Yeah, it's first launch is still the later this year. I'm trying to remember which one, but I don't remember right now. Sorry.
All right, we'll take 2 more questions here. Let's take one right here in the back, and then we'll come to the front and wrap up.
Hi, it's Jane Wells with CNBC. Another question for Hans. Have you been able to give a real world figure of how much it costs to configure a rocket to be reusable, the cost it costs to retrieve it, the cost of refurbishing it to relaunch, versus just building a new rocket? What's the differential?
I don't think I have a number for you, but I know that we're working on that. Basically, there's a couple details here. Obviously, if you have a drone ship out there, it's going to be more expensive. We know how much that is. And then on the flip side, if you land on land, you don't have to wash it, get the salt basically off, right? And so there's less refurbishment on the land side. In fact, our goal is to get to very minimal refurbishment at all, and to basically fly the rockets after an inspection as soon as possible. What's going to be the stuff we're working on is that the trajectories are different, the heat load is different, and so we have one data point at this point in time, and we are continuing to work towards more data point, especially from the drone ships.
Can you tell me what the data point is? How much?
In terms of, I don't want to give you the number on the drone
Okay.
ship. It's expensive.
All right, let's go right here. We're going to take two more, and then we're going to have to wrap up.
I just have a real quick. That was really interesting what you said about the capability to retrieve Dragon if by chance there was an accident. But is there a plan to, does SpaceX have a contingency plan to deploy a ship? And how long would it take to do that? Or how far down that road did you not want to go?
So we do have a contingency plan. That's actually a requirement when you launch rockets, that you have contingency plans. And obviously, in this particular case, we do have boats out there in general for landing the first stage, and we would redirect the boats in this case. Actually, on this particular trajectory, you're never that far offshore. I'm pretty sure it's easy to relatively easy to work with the Coast Guard and get some help there. So that would be our primary approach, working with the Coast Guard. I don't hope you're going to use that, frankly.
Okay, last question right here.
Mark Gotch, Historical Space Imagery. Hans, can you tell me, with the adaptation of the Merlin engines, how much more thrust, torque, do they supply compared to the previous engines on the Falcon? And a question also on the payload. The Bigelow, what portion of the exact total weight of the payload does it incorporate? What does it weigh?
So regarding the Merlin engine, it's 20% more. It's a good amount of thrust. And with respect to Bigelow, you said earlier it's
3,100 pounds.
3,100, and on top of that is a structure that holds it down in the trunk, and that structure is pretty substantial. So there's a couple of thousand pounds that come to that. I think the total is like 6,000 or 7,000, at the top of my head.
All right, that's going to conclude our briefing. Our launch coverage on Friday afternoon starts at 3:30 p.m. Eastern Time for a launch at 4:43. And for additional information about this mission, you can go to www.nasa.gov/SpaceX. Thank you very much.